right, so let's get started. This is going to be the section 1.1. Basically, I'm going to go through this as a review real quick. So this will be a fast lecture here. Guys, let me get back over here, click on my slides and get going. So we're just going to basically cover the concepts of a rectangular coordinate system. We're going to be going through when we start with the rest of the chapter, it's talking about functions, how things are related between some input and output, or the x values and the y values. So we're just going to kind of go through here, look at the graphs, and we're going to be talking more about graphs as we go along. Okay, so what we want to do is be able to plot points on a rectangular coordinate system. What's a rectangular coordinate system? That's this set of x and y. So what we want to do is just basically set up a coordinate system using x and y, so two sets of numbers. So in the past, we kind of used this notation 2, 3 to represent an interval like 2 less than x less than 3. Unfortunately, this has this is associated with two different concepts: the interval notation and then a point on this coordinate system. So this should be at right angles. Basically, this is down, but my graphing isn't that great. And what we're going to do is just do two number lines. Okay, 1, 2 out, -1, -2. This is 0. That's our number line, just like we always did. Plus infinity, minus infinity. But now we're going to overlay it with a number line going in the vertical direction. So above the horizontal line, that's going to be our 1, 2, 3. Ideally, this is the same scale as my x, but it doesn't have to be. This could be 100, 200, 300. Okay. Oh, so let me do one thing right here. Sorry. Okay. So I've got here, I want to plot the point 2, 3 from here. And what I'm going to do is just go over 2 in the x direction. So now I'm going to use a different notation. This is going to be a point with this coordinate is going to be the x and this is going to be the y. So for a 2, 3, I'm going to go over 2 and then up 3, and I'm just going to put a point. And I notate that point as 2, 3. Those are the coordinates of the point. So it's just a little circle. Closed circle meant that, yes, that point is included, but I could also remove a point by doing a circle like we did before. Okay. So plot each point here on this graph, the 2, 3. The 2, 3 would be the 2 over 3 up. It would be a point right about there. -4, 6 would be -4 in the x direction, and then up 6 would be right about there. 0, 2.5, 0x, so we're right here, and then 2.5 would be right about there on the y-axis. This is called the y-axis. This is called the x-axis. Okay. So there's a couple of things that we will use going forward. One being the distance formula. So if I've got 2 points, if I have 2 points on this coordinate axis, so let me kind of resketch this thing rolling. Okay, so if I have, here's how this works. Got an x and a y, and then I'm just going to draw real quick here some hash marks. 1, 2, 3, 4, 10, 20, 30, 40, whatever scale I need. And if I have 1 point here, and I'm going to call it P1, I'm just going to label this as P1. It has coordinates, whatever this is, x1, y1. This is so I can show you this general formula over here. I have some other point 2, and what I usually do is label the first one going left to right, just like we always did when we were doing intervals. From left to right, the first point I see, I'm going to label P1, and then I'm going to have some other, the second point, P2, and so forth. But this one has coordinates x2, y2. So this could be 1, 2, 3, 5. Okay, and the distance, if I took a ruler and measured that, that's the distance. would be the square root. This is basically building a right triangle and doing Pythagorean theorem, okay? And that's what this is basically going to say. It's going to take x1, or x of 2, the second one minus the first one. That's simply the distance here. That's just a straight distance, the distance between 2 points. I square it like Pythagorean theorem. And then I'm going to add my y2 minus my y1 squared. And that's this distance, the y2 minus the y1 here. Okay, and that's just the general distance formula. Let me clean this up a little bit for you. There. So that's what this is basically given. Here's your P1, here's your point 2 with coordinates Q, x1, y1. Point P2 with coordinates x2, y2. That's what that looks like if I was doing this on a whiteboard. And that's the distance between there. Okay. So here's an example. Find the distance between these points. You would just basically do, here was my x1, y1, x2, y2, and then I calculate those out, okay? So for that, my distance, I'm not going to do the full thing. This is how I would set it up. So I would say, here is my P1. It has coordinates -3, -4. My P2 has coordinates 3 and 0. And then I would do just the formula. My x2 minus my x1 would be -3, -3 squared. Plus my y2, here's my x's, here's my y2, -4 minus 0 squared, y1. And then this would just be the square root. -3, -3 is -9 squared plus 16, and then that would give me the square root of 97. Okay, so that's the basic distance formula. And again, this is kind of a review stuff. You can also determine if the given points form the vertices of a right triangle. So you're given, here's A, B, and C, some points A with coordinates -2, 1, B with coordinates 2, 5, C with coordinates 5, 2. And once you do this, if you do your distance and your distance, and then do your distance between the third, and if they follow this relationship, then that's a right triangle. Okay. So whatever the longest, so you'd calculate your distance between A and B. So basically, this is what you're doing when you're doing this kind of. You just plot your 3 points. So A has -2, 1. So -1, -2. -2, 1 would be right about there. That would be your A. -2, 1. And then B would be 2, 5, 2, 1, 2, 3, 4. Somewhere up here would be my 5. A is -2, 1. Okay. And then C is 5, 2, 1, 2, 3, 4, 5. Somewhere here, about here. Okay. So what they're doing is saying here, I've got this, 3 points. Does this, is that a right triangle? Does that form a right triangle? Okay, so you would need the distance, and I'm going to use this kind of notation. I would do the calculation between these two, A and B. Here's my C. I would do the distance formula between B and C, A and B, B and C, and then the distance between A and C, this. And I would see if I'd pick out the two shortest ones, the two shortest distances, and then I would see if this squared. So I would check hypotenuse, the Pythagorean theorem. If I call this like, A B, C. And if I did the longest one, the C squared equal to A squared plus B squared. If yes, then it's a right triangle. Pythagorean theorem only holds on a right triangle. We can calculate the distances. We take the two shortest one. The hypotenuse is always the longer version of the leg. And then we go from there. Or the shortest, longest. Okay. It is longer than these two, the two smaller versions. That would be a little longer than there, than each one of those. Okay. Okay, so that's that kind of piece of it. So let's kind of go through, make sure I haven't seen anything. There's also a midpoint formula that we will stumble upon every once and again. Again, if I draw my coordinate system with x-axis and my y-axis, and if I've got 2 points, right, and each one of these has its own coordinate, I'm going to label this again, P1, P2, x1, y1. This has coordinates x2, y2. And if I wanted to know what the midpoint of these two are, this is the midpoint, and this is the formula. The coordinates is x1 plus x2 over 2. It's halfway between the x1 and the x2 here, and then halfway between those. y2 over 2. So the fundamentals of plotting points, and I'm sure you guys have seen this before. You just basically, I want to graph an equation, so I've got an equation, equal sign, but this is now I've got two variables. Okay, so while we were doing our review, we would just have here solve this particular equation, 2x plus 3 is equal to 5. 2x squared minus 5x plus 6 equal to 0. We'd solve these things, but they were only one variable. These were one variables. Okay, but what if we have two variables? Two variables, you got to give me the x and then I plot the y. So if I have this, if I have y is equal to x squared plus 3, you have to give me the x and I calculate the y. So that's basically what this is saying to do here. And if you were just going to do, I have no idea of what this thing looks like. I'm just going to pick some points. It's really not a very good way of doing it unless it's really, you know something about it ahead of time. I do, so I'm going to pick particular things. I'm just going to say, give me some x. I'm going to build a table. You provide the x's. Let's go -2, -1, 0, 1, 2. These are nice and symmetric about 0. I know that is as well. We'll talk more about that and how we're going to look at a lot of different things to kind of know things ahead of time. But we're just going to calculate y. And how do we calculate y? I'm going to take whatever x value it is. I'm going to square it and add 3. Okay? And then I'm just going to plot those points. So here would be -2 squared, 4 plus 3 is 7. -1 squared is 1 plus 3 is 4. 0 squared is 0, so that would be 3. And then I'm squaring the same thing. It's the same number. -1 squared is 1. 1 squared is 1 plus 3 is 4. 2 squared is 4 plus 3 is 7 again. And then I'll just basically plot those points to generate a graph. And the graph is basically smoothing out what's in between these things. Okay, so I need a little more room than this. Let me kind of go possibly out here. Not much in the x direction, but I need some y direction here. Okay, so let's see if I start at 0. The 0x equal to 0, y is equal to 3. 1, 2, 3, 4, 5, 6, 7. I need at least 7. So for 0, I go up to 3. There's my point 0, 3. Where things cross the y-axis, that's called the y-intercept. Yeah, the y-intercept. 1, 4. I only go to 1, 2, negative 1, negative 2. Okay, so at 1, I go up to 4. That's right there. Negative 1, I go up to 4. That would be right there. 1, 4, negative 1, 4. Then at my 2, I go to 7. So this went all the way 4, 5, 6, 7. So 2, 7. And then negative 2, 7 would be right about there. Okay, so I've got these points, and assuming that I went through and it was a nice smooth function, a nice smooth graph, we'll talk about that as we go forward. We just kind of draw in, sketch in where this goes, and we're going to assume that it continues to do what it's doing. Continue to do what it's doing. How do we know what it's doing? We'll learn more about that as we go through in math. There's more analysis that we can get to do up front. Is there any problems with the equation? Is there any holes, any of those things? Okay, but that's the basics of sketching a graph by plotting points. We're going to do a much better job. We're going to be able to analyze this thing and just kind of look at it and draw its graph. Okay, but if I need some detail with points, I kind of go back and do these, fill in these things. Okay, we'll learn the different things, how we go through all of these things as we go. X and Y intercepts, that's what I was telling you before. Estimating it from a graph, here's the x-intercept, is where the graph that we sketch touches the x-intercept. And then we would say the x-intercept is x equal 1, 2, 3 right there. 3, 0, the y is 0 here. This is the y-intercept. X is 0 here, and then 1, 2, 3. Okay, so we would have, if I label the x-intercept and y-intercept of that graph, I would say x-intercept. That was our 3, 0. X is 3, the y would be 0, and then the y-intercept would be 0, and then I just go up and find that to be 3. That would be the x-intercepts and the y-intercepts from the graph. Okay, so we'll go through, let's see. Graphing utilities, we're not going to do anything with the TI, that's a lot of this information. But what we're going to do is actually use Desmos. And let me show you what that is real quick. Hold on just a second. I need to... get a new window here. Let me try it a different way if it doesn't want to do that way. Okay, so there is website. Go ahead and write this down, www.desmos.com. We're going to use that a lot for our graphing. Okay, and just start your graphing calculator. Let me open this up for us here. And here you've got, here's the Cartesian coordinates, and you're able to do those things like y is equal to x. I'm going to do the caret, shift 6 to give me the caret, to give me my exponent, just like I do on a calculator. I go out of it and then do plus, what did we have a while ago? Plus 1. And then that's our basic graph. So here, if I click on it, it lets me know what the y-intercept is. I have no x-intercepts here. But the 1, you remember when we calculate, I could go over here and click. And if I kind of slide down to get the thing, there's my 1, 2. And here's my 2, 5. Negative 2, 5. Okay. And this is really nice because later on, I'm going to introduce this thing. Well, This could be a different value. What does this do for us? That K, this thing right here, just shifts us up and down. It's the very same graph. All I'm doing is just adding things. Okay, so if I did down here, now I've got a y-intercept. I just go click on it, negative 2.8, and here 1.673 and negative 1.673. So that's Desmos. We'll use that a lot as we go forward. I just want to go ahead and show you that. Let me leave. And that's basically the section 1.1 review. And that finishes that up.